to the road. Dynamic loads are bumps and vibrations. So very high frequency or very little duration for the solicitation. Okay. So sample for static loads, parking in this way is a good thing, and usually for short car having one wheel on the curb. So loads, nature of the loads, this is also interesting. Usually we have dynamic loads, which are the most difficult to forecast and so make a proper calculation. Bump or uneven road, for example, but also some misuse for the car or accidental maneuvers. Type of loads, crash and misuse, but all the time you have operative loads anyway, and the manner of failure. So you can have static, which is obviously the basis for calculation, fatigue, which is the normal end of life for a frame if you have not an accident, or a crash if you have an accident. Constant loads, in terms of you have for a long time a vertical load like this. Anyway, in the family you can include the vehicle weight. If you have a load on the roof for snow, this is distributed on all the roof, and imagine the difficult to provide a roof resistance if you have an open car with a canvas roof. But anyway, this is a kind of calculation which is usually included in the bodywork calculation. And the car parked with a wheel on a curb. Dynamic loads, you have instant application of loads and forces, also extreme forces like crashes. In the first part of the design, you have not all the dimension and weight and solicitation possible for the car. Simply the fact you are still designing and dimensioning the parts and selecting the solution and the materials make the difference, because the weight and the distribution of the weight and the resistance are all related to this. But anyway, you have not this kind of application, but you start from some standard definition. You imagine the target for weight, the distribution, and physically the first packaging of the car. Okay, for the load condition, we can introduce a further distinction in terms of the variable way, the variable load, only in the internal loads due to the transmission. So if you have fast acceleration, if you have a powerful engine, you have very high adherence between the wheels and the road. They also change in stress to the frame. The position of the passengers and the mounting points for the set belts also make the difference, and the other weights which can be concentrated or distributed on the chassis element. Okay, they are the load condition to be considered. Parking and solicitation start from the dimension of the car and the position, theoretically, in this first consideration, position of the gravity center or mass center. So you consider anyway the wheelbase and the distance to the front and the end. The limit condition, parking with a wheel on a curb. So I only propose to you the philosophy of the calculation of a chassis, but we don't need anyway to have an idea for this. Simply, this is for a complete overview about the vehicle engineering, and also may be useful when you are designing something by considering the need for a structure inside of the body of the car or your style, which is proportional to the extension and position of the wheels and concentration of weight and the body masses. So when park with a wheel on a curb, you introduce the maximum torsion. For calculation, you make the hypothesis, you lift one wheel, only one wheel, till you lost the contact on the opposite one on the same axis. It's something like you are jacking up the car from this corner. Okay? So if you lift enough this corner, first or later, you lift also the other wheel on the same side. You try to tilt over the car, if I can see that. The condition is if you are compressing this one, this is completely unloaded, this is compressed completely, and also this other one is in a different manner unloaded. So you remain with 3 contact points to the ground. This is physically the trial you make on existing cars when you are testing the torsional stiffness of the car. Okay, this is for give an easy imagine. Another load you take in consideration when you make calculation is this other one. The complete weight of the car is side applied only on 2 external parts. This is different. This is different to simply consider the weight of the car simply on the side, because you imagine the contact point is still on the wheels. So you have also the suspension completely different, loaded, and so the transmission of the effort to the mounting point and all the other elements is changing. For the standard and also including some exceptional solicitation for bump or other things, a good starting point is always consider 3 times the real weight of the car to calculate the effort and stiffness of the mounting points, suspension element, and other things like this. Okay, this is for basic information. So if you start with 3 times of the mass of the weight of the car as the force stressing the elements of the car, this is a good starting point. Okay. for be clear as possible, torsion is the upper figure. So you twist the body of the car in the two opposite end. The bending load is simply having two stands to the end of the car and applying the load in the middle of the wheelbases or the end of the body. This is more correct to imagine having the standing, the support, the jack in correspondence to the axis, because this is the real condition, okay? Imagine sometimes you also can measure a deformation of the car even in the front overhang and rear overhang, simply because you have a flexible shelf or floor with the weight of the engine and other parts, and you have not enough rigidity on this part. So you can also measure a deformation in this part to the neutral theoretical neutral middle axis of the design. Okay, this is all right to you till now?
Yes.
By the way, an interesting application for this is also simply assembling a car. This bending load is proportional to the weight of the car, okay? So if you are building a new car, usually you are on a bench without all the weight and all the mountings. So you risk, if you assembly the doors and you adjust the door position to the hinges and strikers, with the car not lying to the ground with its own weight on the wheels, you have a different conformation of the body. Only when you have the car on the ground, you have the final configuration, and so you can also adjust the gap and flush of the door. This is the correct way. So you have always a deformation under load of the body. This is not so incredible. This is common. So if you know this kind of imagine, this is a normal device, a bench test for measure test torsional resistance, torsional stiffness of a unitary body. This is a normal and so diffused kind of construction for a frame. So this is included and unitary with the body of the car. And you have an idea of the rear end of the car is fixed to this transverse beam. These pillars are not moving at all. This front beam is rocking, is tilting on this center fulcrum and is linked to this parallel beam, which is moving like the upper one. The front suspension mounting are linked to this beam here, okay? So this rear beam is fixed to the rear axle mount with no springs, no dampers. They are rigid links. And you have hydraulic jacks moving one direction and the other direction, they apply a force, a fixed force. You choose the amount of force. All these measure gauges are aligned along the side of the body, so you can measure starting from the unloaded condition to the loaded condition the single deformation in several distance in several parts of the body, because you can also imagine this is not a constant amount of torsional deformation, but the body is more rigid in this rear end. When you have a closed panel, is easier to deform in this open part when you have the open for the door. Okay, so you can identify the distribution of the deformation under a defined amount of torsional load. All the manufacturers have target for a minimum torsional resistance of the body. So if you have too much deformation, or you have too much concentration for deformation in a limited part of the car, you can also introduce proper stiffening into the body of the car and the frame. Okay, this is the intention of the test. Bending is realizing a too rigid part for blocking the car. You can see also the, maybe I can enlarge the picture. Even if you see the disc rotors, the brake rotors, imagine the suspension is blocked, because this is not really the McPherson's truth, but is a rigid, a solid mounter. Okay, there is no spring and no movement for this. The same on the rear. They are blocked on the front and rear fixing point. The center beam is positioned for the calculation in the middle part, in the center of the wheelbase, and this is the hydraulic jacket, which is pushing down. So you choose the amount of load you want to transmit to the floor of the car, and you can identify and check the deformation in all these part of the floor. So you have the deformation diagram. So the remaining part of the presentation is only for having an idea of long distribution for unevenness of the road. So this kind of long waves, or if you have potholes in the road, they are more common in city roads. Unfortunately, also you know, Rome is a celebrity for the amount and the greatness of this kind of holes. But even if you imagine the ralenti bumps and all the other accidents in the town, they are representing this kind of unevenness. This other one is normal to have on open roads. The intention is to introduce the kind of solicitation they produce, because the peak for a very little time is concentrated on the suspension and wheel and the mountings. This other, on long waves, is introducing the problems due to this kind of proportion between the dimension of the car and the distance between two waves. So you have a parallel vertical movement, so no pitch of the body, if you have a distance which is corresponding to entire proportion of the wheelbase. So imagine the meaning is both the front and rear wheels are going up or down in the same moment because they are always in contact to the top part of the unevenness at the same time, or the bottom part of the wave. Okay? Pitch is the reverse condition. One end is on the top of the mountain, the opposite axis is deep down in the valley. Okay? So we also introduce some simplified structural models. They are used for evaluate basically the main organization of the structure, and also local concentration of efforts. So in these two cases, you can see the CAD representation for the main component of the structural part of the body on the left of a normal car, and this other one is a space frame realized to evaluate other main components of effort. So you